Good morning, class. In last class, we have seen the change of state of matter. Matter, as we know, exists in three different states: solid, liquid, and gases. And we have seen is how the intermolecular space, that is the space between the molecules, and the intermolecular force of attraction, that is the attractive forces between the molecules, differ from one state to another. So we came to know that in case of solid, the intermolecular force is the strongest. So the intermolecular space, the space that is present over there, is practically absent. That means the intermolecular space is very, very less, since the molecules are closely packed. So these molecules can't move from one place to other. They only just vibrate at their own place. Whereas in case of liquid, the intermolecular space is greater than in case of solids, and the intermolecular force of attraction in liquid is not as strong as that in solid, because the molecules are a little bit far away from each other. Okay. Now, the molecules in liquid can move from one place to other within the liquid. That is why the liquids have got the ability to flow. And in case of gases, the intermolecular force of attraction is the weakest, since the molecules are very far away from each other. And the intermolecular space in gases is the largest in comparison to solids and liquids. Okay, so this thing we discussed in our last class. Fine. Now today we'll see why does a change of state occurs. Okay, why does a change of states occur? Say for example, when a solid substance is heated, okay, this is a solid where the molecules are tightly packed. When a solid substance is heated, its molecule gains kinetic energy. As we know, kinetic energy is the energy possessed by the virtue of its motion. So the molecules try to overcome, when it gains kinetic energy, the molecules try to overcome the intermolecular force of attraction. So they vibrate faster and start to move, and the intermolecular space between them increases. So when they gain kinetic energy, the intermolecular force of attraction try to overcome, and the molecules move faster, and so that the intermolecular space between the molecules will increases. If the temperature continues to do so, increasing, at certain point the intermolecular space between the molecules of the solid increases, and the intermolecular force of attraction decreases. Eventually the solid changes to liquid. So when the intermolecular space increases, eventually the solid changes to liquid. So further increase in temperature to the liquid can lead to the more increase in the intermolecular spaces, and intermolecular force of attraction decreases. That will lead to gases. Okay, this is how the change of a state of matter will take place on heating. Fine. The key points that you need to remember about the intermolecular space and the intermolecular force of attraction: the order of their intermolecular space. This we have seen from our previous classes. So this is the increasing order. Okay, gas will have more intermolecular space than liquid than solid. And similarly, when you consider intermolecular force of attraction, this is the decreasing order. Solid will have a very high intermolecular force of attraction, then liquid, then gas. So this is the order for the intermolecular space and intermolecular force of attraction in case of matter. Now, next we see what happens the substance on heating. Okay, so we have made a column, so in which we have got three columns. The first one is parameter, then the process we call melting, evaporation. Okay, before to understand this term, okay, we know that when a substance changes from solid to liquid, we call it a melting, and from liquid to gas we call it as evaporation or vaporization, and from gas to liquid we call condensation, and liquid to solid we call freezing. Okay, these are the terms related with the change of state. So parameter, then melting, evaporation or boiling. So change of state. In melting, what will happen? Solid will changes to liquid, and in evaporation, liquid to gas. So what will happen to the intermolecular space? In case of solid, it is very close, so when it converts to liquid, it becomes close. Similarly, in evaporation, from close to far apart. Intermolecular force, what will happen? In solid, it is very strong, and in liquid, it becomes not so strong. In case of evaporation or boiling, not so strong, it becomes weak. And movement of molecules. In solid, we know that vibrating about a fixed position, they do not move, whereas in liquid, start moving from one position to another. And in case of evaporation or boiling, moving from one position to another, and after that, when changes to gases, it start moving randomly in all direction. This takes place on heating. Okay, next we'll see on cooling what will happen. Again, we'll make a 3 columns parameter, then we put condensation and freezing. Okay, change of state. So gas to liquid is called condensation, and liquid to solid be called freezing. In intermolecular space, what will happen? In case of gas, it is far apart, then it will come closer, whereas in freezing, it is close, it will come to very close. Similarly, intermolecular force is weak in gas. When it converts to liquid, it becomes not so strong, and then after that, in freezing, it's not so strong, it becomes strong. And movement of molecules, moving randomly in all directions, start moving from one position to another, whereas in freezing, moving from one position to another, vibrating about a fixed position. So this is the change that occurs on cooling. Now, assignment for today. Question number 1. When a solid is heated, its molecule gains dash energy. Question number 2. When a gas is cooled, what happens to its molecule? Question number 3. A solid changes to a liquid on heating. Why? So you need to explain it. Okay, so this question also you need to explain it. What happens when a gas is cooled? That means when you bring down the temperature, what will happen to its molecule? Similarly, question number 3. A solid changes to liquid on heating. Why this happens? Question number 4. Write the increasing order of intermolecular space between solid, liquid and gas. So you need to write down the order of their increasing intermolecular space between solid, liquid and gas. Complete this assignment and send it in my mail. Thank you.